Hello everyone, welcome to Unit 5, Lesson 3. This lesson we're going to look at probably the most important type of function, at least at the high school level anyway. We're going to look at quadratic functions, and this is a fairly long lesson, but it really does just break into a couple parts. One of them is just describing all the different features of quadratics, and you might be wondering why I spend so much time or put so much notes on understanding the features of the graph when you could just enter these into your calculator. But you have to realize that when you move into post-secondary, you will be required to understand basic graphs without a graphing calculator, because you won't need or you won't be allowed to use a graphing calculator after completing high school level math. So it's important for you to learn about the basic shapes, which is what I'm trying to introduce to you now, so that you could build on them in your 30 pure and then eventually remove the calculator. So I'm going to review some properties of parabolas in the first two examples. I'll show you how to create an equation of a parabola in the next two examples, and then the last thing we'll do is we'll do a couple examples where we're going to solve parabolas using the graphing calculator. I've already showed you how to solve quadratic equations in a previous unit by factoring, completing the square, quadratic formula. Now you'll be able to solve using your graphing calculator as well. So we'll go through 6 examples here. Our first example is having a look at this type of parabola. What we're going to do is state a bunch of the different properties, and it's going to be important that you try to memorize these properties as quickly as possible and realize that yes, you can graph to figure this out, but the faster you can pick these properties up without having to use your graphing calculator, the easier it's going to be. So the first thing I'm going to do is I'm going to give you what a general sketch of this graph looks like. And what I use is I use those A, P, and Q values. The A value is the coefficient in front of the squared term. So that's representing 1/2. And that's going to stand for our vertical stretch factor. The P value, this is always the one that tricks students the most, is the P value always has the opposite sign of whatever you see in the brackets. So you see a minus, that means P will be positive 1. Where if I see a plus inside the brackets, P will have the opposite sign. So P always has an opposite sign. It's the way that the form is written. It's written in x minus p form. So that means p is the positive number when you subtract. And that's going to stand for our horizontal translation. And in this case, since there's nothing being added to this function, our q value is 0, meaning our vertical translation. So once you know those different values, you could draw yourself a sketch, which means you don't have to be very accurate, but x minus 1 squared is going to give you a parabola that's going to be shifted 1 unit to the right, and a q value of 0 means it's along the x-axis, and it's going to open upwards because the a value is positive. So when A is positive, I describe it as being a happy face. When A is negative, I describe it as being a frown, and it'll open downward. Whereas if you had a Q, it's going to tell you how much up and down you move. P is going to tell you how far left or right you're going to move. So there's a sketch. If you actually put this into your graphing calculator, you could confirm it. But I'm going to use my sketch to answer the questions. The direction of opening is up. The stretch factor, I don't tend to use the word shrink, and we don't use the word shrink in 30 pure. We just always describe it in terms of its stretch, and we'll use factor 1/2. The domain, well, we've been practicing some domain and range already. So the domain, but we already know that with quadratics, they go forever left and right, so they're going to be an x as an element of the real numbers. The range of this graph, since it starts at 0 and goes up, our range will be y such that y is greater than or equal to 0 and a real number. That's where the sketch really helps. The equation of the axis of symmetry is another one that tends to throw people off. Whatever you have in the brackets is your equation of axis of symmetry. So it's x minus 1 equals 0, or you could actually solve it for x and write this as x equals 1. Another way to think of your axis of symmetry is your axis of symmetry is your p-value, because that's going to be the line that this graph is a mirror image of each other. That's what we mean by axis of symmetry. It's what cuts this thing into two equal pieces, is another way to look at it. The maximum or minimum, well, that's going to depend on the direction of opening. Since this thing opens up, we're going to have a minimum, and the point is going to be the point P and Q. So the minimum occurs at that vertex, which is going to be the point 1, 0. And that kind of answers my next question. The coordinate of the vertex is also going to be 1, 0. This magic point, which I state in your notes, represents the vertex, and it's the point PQ when you have this in standard form. So ideally what you want to do is you want to be at the point where you don't need your graphing calculator to help you with all these values, and it takes quite a few examples to be able to do that, and a little bit of time of reading through all these notes I've given you. But once you get this, it sure makes dealing with quadratic equations in pure 30 so much easier to deal with, because you have a picture of what all these quadratic equations represent. So let's look at a second example here. Example number 2, same thing, another parabola, but again, always pull out the A, P, and Q. So A is 2.5. P in this case will be negative 1.5, opposite sign of what's in the brackets, and Q is going to equal to negative 9. So if you were to think of this graph, again, if you wanted to sketch it for yourself, and a sketch doesn't have to be perfect, but because the A is positive, it's going to open up. Because the p-value is negative, that means we're going to go 1.5 units to the left, and we're going to go 9 units down. So it would be down here if I wanted to do a sketch. And since it opens up, there's going to be my parabola. Not the greatest looking parabola, but you get the gist of what I'm discussing here. This represents our vertex, PQ. So again, we can state our direction of opening. This case it'll be up because A is positive. If A was negative, we open down. The factor, the stretch factor, is the A value. So it's a factor of 2.5. The domain and range again. The domain of all quadratics, by the way, is always going to be x such that x is an element of the real numbers. In lesson 1, I was telling you that. Now you're actually proving it. The range in this graph, this is where the sketch helps. The lowest point of the graph is going to be negative 9. So it's y such that y is greater than or equal to negative 9. It's every value above, greater than that minimum. The axis of symmetry again is going to be whatever's in that brackets, x plus 1.5 equals 0, or x equals negative 1.5, whatever your p-value is. The maximum or minimum, this case is another minimum, and it's the PQ value, negative 1.5, negative 9. And the vertex, same thing. We usually use V for vertex, is going to be negative 1.5, negative 9. Again, if you want to enter these into your calculator and hit your graph key, you can verify these for sure, but try to do these without the graphing calculator. What you should do is just use the graphing calculator to check. That's going to show understanding of the properties. So there's two examples that are working with A, P, and Q. The basic parabola is y equals x squared, and what we do is we stretch it, we shift it, left, right, up, and down, and then what happens in 30 pure is what we do with parabolas, we extend to every type of graph. So we end up doing this stretch, this shift, right in the first unit of 30 pure. So understanding this is really going to help you get off to a good start in Pure Math 30. The other thing that you do get asked quite often is to come up with equations of a graph. So if you're going to write an equation of the graph, always start with the standard form ax minus p squared plus q. Start with this. And you will need 2 points on the graph, preferably the vertex and some other point. Once you know the vertex, you know the p value and the q value. Some other point on the graph will stand for x and y. So what you have is you have x, y, p, and q. You can put all those numbers in and solve for the one number that you're missing, which is a. And then once you know a, put in p, q, and a, and there's your equation. So I'll show you how that's done. Do the substitution. Y is going to be 0. A I don't know. X is going to be 2. P is going to be negative 1. So it'll be 2 minus negative 1, which will be 2 plus 1 squared plus 3. So 0 equals 3 squared, which is 9a plus 3. Negative 3 equals 9a. Divide by 9. 3/9 is negative 1/3 equals a. Now this value, if you understand the properties, should make sense. The graph opens down. That means our a value better be negative. It is. So when you want to write the equation, therefore, the equation is, all you do is you put in just a, p, and q, because you want to describe every point of x and y, not just the point 2, 0. So you put in a, negative 1/3, x plus 1 squared plus 3. And one of the final two examples will have us drawing this graph. And if you were to enter this graph on your calculator and to check your table of values, and that's one of the things I encourage students to do after doing this approach algebraically, enter this into your calculator. Those 2 points better be in your table of values. If those 2 points are not in your table of values, that's telling you you've done something wrong. Those are the only 2 points that should satisfy, well, I should say only. There's lots of points that satisfy this equation. But another equation may have 1 point, or it may have the other point, but any other equation wouldn't include both of those points and be a quadratic. All right, let's look at another equation. This one I'm just going to give you a word problem form. Write the equation with a parabola with a vertex of, so we list our vertex, negative 5, negative 3. That's going to stand for P and Q. We have another point of negative 3, negative 11, and that's going to stand for x and y. Start with our standard form, x minus p squared plus q. Put in all our values. Negative 11 equals a, x is negative 3, minus a negative 5, which will be plus 5 squared, minus 3. So put in y, x, p, and q. Simplify. I'm going to add the 3 already right now. So negative 11 plus 3 will give me negative 8 equals negative 3 plus 5 is 2, so it should be equal to 4a. Divide by 4, a equals negative 2. This time you don't have a picture to compare that a value, but if it's got a vertex of negative 5, negative 3, and it passes through a point that's further down, right, y value, that means it must have to open downward, if you think about it. Therefore, our equation will be y equals, put in the a value, x minus p, so x plus 5 squared minus 3. The biggest thing that I see students make the mistake when they first start dealing with these equations or first start dealing with properties is they forget that the p value always has the opposite sign of what's in that bracket. You see a positive number, a plus sign, then p is negative. You see a subtraction sign, p is positive. And why is that happen? Because the standard form equation has a subtraction sign in that. So it's always going to be the opposite sign, minus p, x minus p. It's not x plus p, it's x minus p. So because of that, our p value always has the opposite sign, but q keeps the sign. And once you get that understood, again, parabolas become a little bit easier to work with. Alright, let's look at another example. Example number 5. Here's where we're going to practice graphing. And when you solve by graphing, the first step that I want you to do is always set the parabola equal to 0, just like you did when you were doing these algebraically. So step 1, 6x squared minus 5x minus 4 equals 0. Now in the last unit I'd have you try factoring. If it didn't work, I'd have you try using the quadratic formula, etc., etc. Now what I'm going to do is I'm going to show you how to put this in your calculator. So what we're going to enter in our calculator under y1 is 6x squared minus 5x minus 4. And what we're going to determine is the zeros. And I'm going to give you all the different terms. Solutions to the equation is the same thing as being asked to find zeros of the function, or it's the same thing as being asked to find intercepts, or it's the same thing as being asked to find the roots. All of these words mean the same thing. They are asking for the same point on the graph. They are asking for the same value. So when you see those different terms, they all mean to solve. Find the solution, find the zeros, find the x-intercepts, find the roots. Well, I'm going to show you how to do this using your calculator this time. So let me load up the calculator. What we're going to do is just enter the equation into our equation editor. So press y equals, enter in 6x squared minus 5x minus 4. Now we haven't used this form very often, and we don't use it this often at the high school level because you couldn't actually picture a sketch when you're in general form. You don't have A, P, and Q. What you have though is you do have that subtract 4. Because that's a constant value, that will enter or always represent our y-intercept. We also have the a value, which is 6. That's your coefficient of the x squared term. But we have no idea how far this thing shifts up, down, left, or right as a result. We know a y-intercept and we know a, and that's it. That's why we don't use this form very often when it comes to describing properties. Or if we do, what we'll do is we'll graph it and get all our properties by using the calculator. So what we're going to do here is press our graph key, or zoom 6 first to put this in our standard window. And that's what this thing looks like. It opens up. It's a very narrow graph because our a value is 6. And like I said, our y-intercept is -4. Now what I want to do is make this picture a little bit bigger on the screen because it's hard to read. I've got a lot of empty space on the left and a lot of empty space on the right. So I'm going to simplify or make those window settings go from, say, instead of -10 to +10, I'm going to go from -5 to +5. You don't have to do this, but what I want to do is I want to make this thing a little bit easier to see so that when I do find zeros with my calculator, it's a little bit easier to read. Now there's a couple ways to find the zeros. Sometimes you can find them in your table of values if they're integers, but the easiest way and the most efficient way would to be using the calculate feature. And notice where my cursor is, it's pointing at this trace button, but above it in blue is the calculate feature. And if you go second function trace, it'll bring up an option called 0. Choose that. By the way, you can also find minimum and maximum of your graph. We don't do that in this course, but in the actual Pure Math 20, they use that feature quite often as well. We just tend to use zeros more often. So we're going to find the 0. Now how the calculator works is you can see there's a little flashing cursor that'll come on the screen. What you have to do is you have to tell the cursor where to look. And what you have to do is you have to think of your graph from left to right, just like how you read a book. And your graph on the left side and your graph on the right side, because you have to tell the calculator where to start on the left, where to finish on the right, and you have to include the 0 when you do that. So notice in this case, and students always make the mistake of thinking above and below. Do not think that. What you want to do is, this is a 0 you're looking for, an x-intercept. When you think of that 0, you want your cursor on the left side of the 0. Right now I am on the left side of the 0 on that line. Hit enter. You'll notice there's a little triangle that shows up. Use your arrow key to cross the 0, and once you cross the 0, then you can go and say, now I'm on the right side of it, and hit enter again. How much you cross doesn't matter. You have to cross. What will happen is if you don't cross the 0, then the calculator can't give you a value. So now that you've got left and right, at the guess, just enter one more time, and our first 0 turns out to be x equals -0.5. So I'll just jot that down for myself. That's the first x-intercept. Now you do this again on the other side of the graph, second function trace, option 2 for 0. And now again, you want to be on the left side of your 0. I am on the left side of it. Hit enter. Use your arrow key, right arrow key, to pass the 0. Then hit enter again. At guess, hit enter one more time. And the other one is 1.33333, which is really 4/3. So that's how you find zeros or x-intercepts or solutions with the graphing calculator. So you could have tried to factor this, and you would have found a factor of -1/2 and another factor of 4/3. You know, you could try solving this by factoring. You've done it that way already. Now you can verify it with your calculator. So I'm just going to take the calculator off the screen for now and write my solutions. Now when you solve by graphing, what you always do is you state your window settings. I used a -5 to 5 and a scale of 1 on my window settings. I'll scale from -10 to 10 and a scale of 1. One thing that they always ask on diploma exams, if you're going to use your calculator, which is fair game, the only thing they ask you to do is you have to include your window settings so that your work can be checked. And then when you state your zeros, the solutions are x equals -1/2 and +4/3, which you would have got the same answer had you factored. You would have got the same answer if you used the quadratic formula. But now you've got another method, solving by graphing. You can use one method to check another. Here's the downside of graphing. Sometimes it's hard to get appropriate window settings. Sometimes it's hard to figure out an exact value, like 1/2, 0.5, and 4/3 are easy to convert to exact values. But you wouldn't know how to find most other more complicated decimals. You'd have to round it. So if you saw exact values or fractions in a lot of those answers, you probably couldn't use the graphing calculator to find that solution. Use the quadratic formula or use factoring. Let's do one more, but this time let's just make it a word problem first. It says the area of a rectangular field is 2,275 meters squared. So we have an area equals 2,275 meters squared. The field is enclosed by a perimeter 200 meters of fencing. What are the dimensions of the field? Well, we'll start by listing them as just x, y. We will create two equations, but we have to define our variables. Let x equal the width. Let y equal the length. And since we have two unknowns, we will have to create two equations. We have a formula for area. Area of a rectangle will be x times y. We also have a formula for perimeter. Perimeter is going to equal to 2x plus 2y. We know what these numbers are equal to, so equation 1 gives us 2,275 equals x times y. Second one is 200 equals 2x plus 2y. Now I quickly see that this could be divided by 2 quite easily, so I can write this as 100 equals x plus y. And since I have two unknowns, I'm going to have to create two equations. So I'm going to take equation 2, solve it for y. Y will be equal to 100 minus x. And now I'm going to go back to something we've done earlier. Substitute equation 2 into equation 1. But every time you have two unknowns, you know you need to create a system. So equation 1 becomes x times y, which is 100 minus x, equal to 2,275. Expand. 100x minus x squared equals 2,275. And what we want to do is we want to check this with our calculator instead of using our other methods. What we'll do is write this equal to 0. I'm going to move the x squared to the other side, so it becomes 0 equals x squared minus 100x plus 2,275. And that's what I'm going to graph on my calculator. I'll do that on the next slide shortly. So with the word problems, just like in the last unit when we were solving word problems back in quadratics, I can bring back a quadratic word problem. We're just going to solve it with graphing this time. You actually did this using the quadratic formula or using factoring back in the last unit. We're just going to use our graphing calculator this time. So on the next slide, let me enter the equation. I had x squared, I think it was minus 100x plus 2275. Equals 0. We're going to graph x squared minus 100x plus 2275 on our calculator. So let me bring up the calculator again so we can practice this one more time. Let's clear out our original equation. Clear. Let's clear the whole history here so you don't get confused. And let's enter the new equation. X squared minus 100x plus 2275. Now x is going to represent one of these dimensions. What we want to do is find out what one of the dimensions are. Then we'll go back to our original formula and find the other one. Now what we want to do is enter this in our calculator, come up with a reasonable window setting that we can use for this. Now what sometimes people do is just start with our standard window and see if you get a graph. Then you could look at your table of values. You can see in my table of values that these numbers get quite big quickly. Well, you can also apply some reasoning to this as well. Since x is going to represent a dimension, we shouldn't have negative x values in here. We should have positive x values in here. So what we want to do is start with appropriate window settings. X should start at 0 and go. We know that the total amount of fencing is going to be 200. So x could never be more than 100 because you have to have two x's, and it would be impossible to have just only two of the sides each 100. But we know if we go from 0 to 100, we will find our value somewhere in between. Go up from 0 to 100, maybe we can start with a scale of 10. Our y values can get quite large. We're going up to a pretty big area. 2275 is a pretty big y-intercept. So maybe what we want to do is go from, say, negative 10 to maybe 2300, 2300, and let's go up by 100s in this case. So you'll play around with your window settings and your scale to try to get an appropriate setting for your graph. You'll probably check with your graph key. If you can't clearly see your intercepts, looks like I should go down a little bit more negative because I want to be able to see the left side and the right side. So maybe what I'm going to do is go, for my window, go from negative 200, since I've got such a big scale, all the way to 2300. So I'm going to go from 0 to 100 in x, up by 10s, from negative 200 to 2300 for y, up by 100s. And I should get a fairly decent picture. I don't need to see the bottom of the graph. What I do need to be able to find is where I cross the x-axis. And I do have enough room to be able to find that. If you want to make this even better, I'd probably go down to negative 400 or even negative 500 just so that you get the graph centered on your screen a little bit more. But this is good enough for me. Let's go find the 0. Second function, trace. Option 2 for 0. Find your cursor. Keep moving it till it appears in front of you. There it is. So 28, and I can see my y value being positive, so I am above 0. Hit enter. I'm going to move until the y becomes negative, because then I know I cross the x-axis. So I'm at negative 60 now. I've passed the 0, hit enter. At guess, hit enter one more time. And one of those zeros is when x equals 35. Let's go find the other possibility. Second function trace. Oops, second function trace. Option 2 for 0. And do this again. Make sure you're clearly past the first 0, negative 220. Hit enter. Use your right until you now become positive. Hit enter again. Guess, hit enter one more time. And the other value x could be is 65. So you may be wondering why two values of x. I'll explain that shortly. But remember the 0 feature. Set a left bound, cross the x-axis, set a right bound. When you do the other one, set the left bound, cross the x-axis, find the right boundary. So let me get rid of this. The values of x could be, just finding out where I put my pen, x could be then 35 meters, or x could be 65 meters. If I go back to my previous slide, y equals 100x, therefore y equals 100 minus 35, y equals 65 meters in case 1, or y equals 100 minus 65, y equals 35 meters. And what does this really mean? Well, you could have a rectangle that looks like this, 65 by 35, or you could have a rectangle like this, 65 by 35. They would both give you the same area. They would both give you the same perimeter, which is why you have two possible dimensions. So we would just say that the dimensions are 65 meters by 35 meters. Now you might be thinking this one probably could be done faster by factoring your quadratic formula, and I agree. Sometimes when the window settings get kind of messy, it takes a lot of work to be able to try to figure out appropriate window settings, and that takes a little bit of time. But you want to make sure you practice that as much as possible. Work on exercise 5.3. Lots of questions on graphing, lots of questions on properties, lots of questions on determining equations. Take care, everyone.